All right, we're also going to talk about factoring special products. First one I want to talk about is the difference of squares. Difference of squares will be written as in the form x squared minus c. Notice how there's no bx term. That's always the case when you have a difference of squares special product. So it looks kind of weird when you write it in algebra, but basically, and sorry, c would have to be a perfect square. So the way you would rewrite this would be x plus c, and then x minus c. And like I was saying, it looks kind of scary when you write it in algebra, but that would be something like factor x squared minus 9. 9 is a perfect square because the square root of 9 is 3. So then the answer, you would just write x plus 3 and x minus 3. So if you ever don't have a bx term, or just that x term in your equation, that's a good shortcut to look for. Well, is the last thing that I'm subtracting, has to be subtraction, perfect square? If the answer is yes, this is your shortcut. The next one I'll talk about is perfect square trinomials, but this one, I think it's easier to just factor. You can use the shortcut if it helps you, but I think it's way easier to just factor it. So for perfect square trinomials, you'll have something written in the form a squared x squared plus 2ab plus b squared. So for an example, plus 16x plus 64. So again, even though we can't see the a value, you can multiply anything by 1. So you can think of this, if I were to rewrite it, so that you can actually see the squares, you could think about it as 1 squared times x. I'm going to skip over the 16x for just a minute because I want to look at the 64. The square root of 64 is 8. So you could rewrite that as 8 squared. And then plus 2 times a times b x. And I forgot the x up there. There's always an x term with the middle term. And so then when you factor perfect square trinomials, it's always going to be written in the form ax plus b squared. For us, we can see that the a term is 1, the b squared is 8. So this is the same as 1x, or just x, plus 8 squared. I would get the exact same value if I factored out the number 64. And I chose the pair 8 and 8. You'd probably write it as x plus 8 2 times. And these mean the exact same thing. I would say you should know that, you should understand that shortcut, but yes, if you would rather just factor, you can still do that. We touched on this earlier, but we didn't fully go in depth. When you are talking about solving a quadratic equation, you are solving for, again, like I said, the roots or the zeros. And that's where you have to set your quadratic equation equal to 0. If you can factor, that's going to be the easiest way to do it. and then set each equation equal to 0 and solve. And I'm saying each equation because you'll be able to factor like x plus 2x minus 3, set x plus 2 equals 0 and solve, and set x minus 3 equals 0 and solve. So it's easier to solve one root at a time if you can factor. So the first example, it says what are the roots of the equation x squared minus x minus 42? We're subtracting the back term, so that means one of our terms will be positive, one will be negative, and the number that we want to factor is negative 42. We're subtracting the middle term, so that means our bigger number will have to be negative. Always start off your list with the number 1. 1 and negative 42. Oops. Two and negative 21. 3 and negative 14. And then 6 and negative 7. So for us, the pair that will add to give us negative 1 is 6 and negative 7. So we could rewrite the equation x plus 6 times x minus 7 equals 0. And then we just set both of those terms equal to 0 and then solve. So x plus 6 equals 0. We get x is negative 6. Solve the second equation, or solve for the second factor. X equals negative 6, or x equals 7. All right, the next question tells us that we want to find the roots of the equation x squared plus 3x minus 28. So this time the number that we're going to factor is number 28. Our c term is negative, or we're subtracting the constant. So that means one of our terms will be positive and one will be negative. Because we're adding the middle term, our bigger number should be positive this time. So always start off your list with the number 1, or for us, negative 1. You have negative 2 and 14. And we have negative 4, positive 7. And it looks like that's the pair that will add up to make 3. Negative 4 and 7. So we're going to rewrite the equation as x minus 4 times x plus 7 equals 0. We'll solve for one term at a time. So x minus 4 equals 0. Solve for the second term. And we have our two answers, x equals 4, x equals negative 7. All right, last question. You have a rectangular vegetable garden in your backyard, and it measures 15 by 10 feet. I always like to draw the pictures as I'm going, because it helps me to visualize it. You want to double the area of the garden by adding the same amount to each side, or the same distance to the length and the width. What's the value of x, and what's the new dimension of the garden? So we don't know exactly what we're adding right now. We just know it's going to be x feet. And same here, it's going to be x feet. So if I were to picture what this new garden looks like, I would have something like this. They told us that the area at first, well, they didn't give it to us, but they told us the original dimensions were 15 and 10. So 15 times 10, we get 150. I'm writing this out right now because it told us in the question that we want to double the area after we add on x. So double means 2 times bigger. And that's going to be equal to whatever this new area is with our x values drawn in. So it might not look identical to something you've seen before when you're talking about multiplying polynomials, but it should look pretty similar because you still have to take 15 times x, and then 10 times x, and then x squared for the x times x. So when we rewrite this, we have x squared, 15x plus 10x, we get 25x. And then this portion right here makes 150. Let's simplify this just a little bit. 2 times 150 is 300. And that equals x squared plus 25x plus 150. The last thing that we have to do, though, because it says solve, we have to set the left-hand side equal to 0. So subtract 300 from both sides. So x squared plus 25x. Now it just becomes minus 150. So 150 is the number we need to factor. And I should say negative 150. And when you have a bigger list of factor pairs like this, I would say you don't need to finish all the way to the end, but get enough to where you see the answer. Always start your list with the number 1. That's not going to work for us. And sorry, we're adding the middle term, so the smaller number should be negative. So negative 1 and 150. Nope, negative 1 plus 150 doesn't make 25. Negative 2 and 75. Nope, that doesn't add to make 25. Negative 3 and 50. Nope, still not quite there. 4 doesn't work. Negative 5 and 30. Negative 5 plus 30 makes 25. So here's the pair we want. So 0 equals x minus 5 times x plus 30. Set both terms equal to 0 and solve. But see how when we solve the second equation, we get negative 30. We don't have negative length. We're not trying to take area out of this garden. So if you have a situation like this, you can cross off any negative answers. So our answer is just 5 feet. All right, good luck.